I probably should have read all of the discussions before posting the last video, because then I could have tackled everything in one video. But now I'm doing a second one. Okay, so this is still example 3.3.2. Okay, and we start off with this matrix, and it says find the value for a which the determinant is equal to 0. And it starts off, and then we do all kinds of stuff, subtracting 3 times row 1 from whatever. Okay, so here's what we're going to do. Okay, we want to find the determinant, and we would like to make it a little easier, and we're always expanding across a row or a column, right? And the more zeros there are in that row or column, the easier it is, because you get a bunch of stuff with zeros that you're multiplying. So what the example is doing here is saying, okay, well, let's create a situation where we have zeros in all of these spots instead of A's, because the zeros are kind of easy. So if I want a 0 in, let's say, that top left one, I'm going to take A times row 3, and I'm going to subtract that from row 1. Okay? And if I do that, my new row 1 is going to be 0, and then we'll have, let's see, A minus A squared. Okay? And then we will have 1 minus A squared. Okay? Now I'll do the same thing for row 2. I'll take row 2 and minus A times row 3, because I want a 0 in that spot. And I do get a 0. Okay, and let's see, 1 minus A squared and A minus A squared. And then I leave row 3 alone. So the sole reason for doing this is to get my zeros. Okay? So now, if I find the determinant of that, I can do my cofactor expansion type thing, and then I will do that along row 3. Okay? um, but now, hold on, I'm supposed to be erasing stuff. Um, because what we have is, or I can do that along column 1. Sorry, I'll expand across that column. That's why I put those zeros there. I don't know why I said row 3. Okay, but if I do that, we get 0 times a bunch of stuff minus 0 times a bunch of stuff plus 1 times, and now we need the determinant, okay, of A minus A squared, 1 minus A squared, 1 minus A squared, and A minus A squared. Okay? And that'll be the same thing, right? So all that boils down to is it makes our calculations a little easier if we can get zeros along a column and a row. Now, I could have just as easily done some elementary column operations, okay, and got zeros on the in the bottom row where those A's are. But we have to be careful about when we do things like that, when we start switching rows, how that affects the signs of the determinants and stuff like that. Okay? Now, just to kind of finish this up, if we look at where is that going to be 0, we say, okay, well, if I look at that first one, I can factor it. And this is the top left-hand quarter is a 1 plus A and a 1 minus A. It's a difference of 2 squares. Okay. Then we have a 1 plus A and a 1 minus A, and that should have been a times 1 minus A there, sorry. And then again, an A times a 1 minus A. Okay. I say, oh, look, we've got this common factor in the first row, so I can pull that one out, and we get a 1 minus A. Okay. And then I look at the second row and go, oh, look, I've got a common factor in the second row. It just happens to be 1 minus A again. Okay, so I can pull that 1 minus A out, and then I just look at the determinant of 1 plus A, look at the determinant of that, say, okay, well, we get 1 minus A times 1 minus a, and then the determinant of this thing is going to be what? A squared minus 1 plus a times 1 plus a. And now let me just simplify stuff. And that's going to be a squared minus, and what are we going to have? 1 plus 2a plus a squared. So 1 minus a, 1 minus a squared, and we're going to have a negative 1 minus 2a. And we want to know, when is the determinant equal to 0? Well, from each of these factors, on the first one, we get that it happens when a equals 1. And then from this factor over here, we get it when it's equal to a 1/2. Okay? But that whole bit in the beginning, which is probably where a lot of the confusion was coming from, right, is just to manipulate it to make calculating the determinant easier. And when we expand across rows or columns, the more zeros, the easier it is. So sometimes the elementary row operations are easy to do to create those zeros to make the determinant much easier, if that makes any sense. Okay? So I hope this clears it up a little bit.